Hello. In the previous video, we learned how to understand how to define a conditional probability. And I'm giving you here in this slide, I show you another example which has the same structure. So the research question we would like to answer is, does smoking increase the risk of high cholesterol or not? So it's pretty much the same structure because like we are comparing the chances of high cholesterol given the condition of smoking, right? Right? So like promotion given female, pretty much the same structure. But here I'm going to show you real data. The previous example had was purely makeup, fake data, so has no like a real world implication except for the method I demonstrate. But here I'll show you the real data. It's pretty simple. So the name of the data is National Health Interview Survey, maybe. Let me see. Yeah, National Health Interview Survey. The data is collected every year, I believe. And my data, what I show you is from 2018. And the data I show you has more than like nearly 8,000 observations. Have a look. So this is, of course, the original data has much more variables, several hundred variables in the original NHIS data, but I only extracted two variables that fit our example. So the first question, the first variable is about cholesterol. Have you ever prescribed for high cholesterol or not? And the second variable is about smoking. Have you ever smoked in your life? Right? Simple. And then, and you know, it's yes or no question. So the answers, the possible outcomes are yes and no for each of the variables. And let's go. So as you see, the first person has been prescribed for high cholesterol and has smoked before. And the second person says no, and yes, no. And this is the typical 2 by 2 format as our previous examples. So it's easy to understand what is going on. It should be 2 by 2 data, but if you go drag down the data, the problem is the size of the data. As I said, there are 7,888 because the first row was the label. So more than 7,800 observations for this data, for these variables. So it is not convenient. It's like actually impossible to understand what is going on in this data just by looking at those numbers, right? The data is good, but we need to summarize the data. That's what we are doing in the first and this chapter. Okay, and then like I'm going to show you how to handle the data later. But before doing that, like I'd like you to think about what we need to calculate. So in our example, in this example, there are two basic events: smoking and high cholesterol. Smoking and cholesterol. And then, given these two events, we can think about many different conditional probabilities, many different operations on those events. But as I said, what we want to calculate, what we want to answer is, does smoking increase the risk of high cholesterol? So this is our question. Then what probabilities do we need to compare to answer that question? Think about that. It can be tricky, but this is the most difficult question in this chapter, like in this part, because once you know what you have to calculate, from there it's just kind of mechanical, like You can use formula or you can just follow a few steps. So what's most important is to understand what we are doing. Answer this question. And the answer is, remember, what we compare is we are going to divide our sample into smoking group and never smoking group, right? Never smoked group and smoked, never smoked. And we compare across these groups and like using the probability, the risk of high cholesterol, right? So the main event is high cholesterol, and the condition is whether a person has smoked or not. That is, the condition should be S and S complement, and the main event should be high cholesterol. So C is the correct answer, right? So we are going to calculate these two probabilities, these two conditional probabilities, and we are going to compare them to draw a conclusion. And our previous data can be summarized into this distribution probability distribution. So it's typical 2 by 2 probability. If you add these four numbers, you are going to get 100%, obviously. So I have shown you how to do this on Excel using pivot table. Today, I'm going to show you how to calculate conditional probability on pivot on Excel using pivot table. So this table is unconditional probability table, but you may change some options to make it a conditional distribution table, conditional probability distribution table. Come back to Excel, and what we are going to do is insert pivot table. Pivot table. I'll just click yes. And this is what we have seen in the last video. And remember, what you can do is, excuse me, put any variable in here because the value is, in the end, it will be count, so it does not matter. And column is high cholesterol and rows are smoking. You may switch them. Then you will see yes, no. By the way, it does not look good because yes, no is not distinguished. So, but here, the first row is those guys who said no to high cholesterol, and this no is to smoking. So now you have to clearly distinguish what is in the columns, what's in the rows. So it's confusing, can be confusing. And now this 2 by 2 table, this 2 by 2 table shows the frequency distribution table. It's frequency distribution. To change it to probability, we click this and then go to value field settings and show the value as percentage of grand total. Then you will get a probability distribution table. So this is 2 by 2 probability distribution that I showed you in the slide, and that's what we did in the first chapter. We are going to change the option again. Here, what we are going to do here is, instead of choosing percent of grand total, I'm going to use either percent of column total or percent of row total. So let me choose this, column total. Then what you get is this probability. So here, these probabilities are percentages calculated based only on this column. So as a result, the sum of the probabilities within the column should be 100%. Similarly, in other words, so when you calculate this probability, it does not use the data in the second column. So that means this is the conditional probability conditioned on this column, which is no to smoking. never smoked. So this is the probability of never smoking group, and this is the conditional probability of smoked group. That's conditional probabilities. And if you want, so this, in this case, the condition is smoking. That's exactly what we wanted to calculate. But if you wanted to calculate conditional probability conditional on high cholesterol, for example, then you can switch it to row total. And then the role of column and row is switched. So think about this. So look at this. Now these probabilities are conditional probabilities based on the first row. So using the information from the row, not using the second row, and this is conditioned on the second row. So like that, you can calculate any conditional probability using like these two options, whether you have column or row percentage, right? So that's how we use pivot table to calculate 2 by 2 conditional probability table. In the next slide, I'm going to stop this video here. In the next slide, we are going to calculate directly from this probability distribution table so that we can extract some kind of formula in the end. Okay, so but as I said, it's important to understand. It's important to use the real data and Excel. So even if you don't understand the algebra, that's unfortunate, but still that's okay as long as you can do that actually on Excel, right? So I hope you to try it by yourself, try many different data available to you, and try to try many different options, see what happened. Okay, see you in the next video. Thank you for watching.